In this video, we'll be solving a quadratic equation by completing the square. The problem that we'll be working with is to solve for x by completing the square. We have 4x squared plus 6x plus 5 equals 0. Now I'm going to show the steps for the quadratic equation ax squared plus bx plus c equals 0 on the left, and then I'll actually do the steps on the right. So our first step is, if a is not equal to 1, divide both sides of the equation by a. Now notice that a is the coefficient of x squared. That has to be a 1 or you cannot complete the square. So in our case, a is 4. So what I'm going to do then is divide every term by 4, and that'll cancel that out there in front, and I have x squared plus 6/4 is the same as 3/2, and I'm going to separate the x just so I can have an actual a value, b value, and c value. So my b in this case is 3/2, and then I have plus 5/4 equals 0. Okay, so your very first step, you must have a 1 in front of the x squared in order to complete the square. It won't work unless you do. All right. Our next step is to rewrite the equation so that c is on one side of the equation by itself. Now you'll notice that c is the constant. This is the x squared term. A is the coefficient of the x squared term. B is the coefficient of the x term. And c is the constant. So we want to take the constant, in this case it's 5/4, and move it to the other side of the equation. So we have x squared plus 3/2 x. And then subtracting 5/4 from both sides. And so it cancels off on the left side, and I have a negative 5/4 then on the right side. My next step is to multiply the coefficient of x by 1/2. Then square this result and add this number to both sides of the equation. So my x has a coefficient of 3/2. So I want to multiply that coefficient by 1/2. And remember, when you multiply fractions, you just multiply across the top and multiply across the bottom. So I get 3/4. Then I want to square that result. So 3/4 squared. When you square a fraction, you just square the top and then square the bottom. So I have 9/16. And then add this to both sides of the equation. So I have x squared plus 3/2 x plus, and I'm adding 9/16 to the left side. And then on the right side I had negative 5/4, and I'm adding 9/16 to the right side as well. So basically you haven't changed your equation. You can't do that. You have to add the same thing to both sides, and this is how we find that value that we add to both sides. I call this the half it, square it, add it step. And my next step is to factor resulting trinomial as a perfect square. So on this side, this is now a perfect square trinomial, which I can factor easily as the square of a binomial. The first term here is the square root of this x squared, so that'll just be x. The operation between the two terms of the binomial is the operation on the middle term of the trinomial, so plus. And then term back here in the binomial is the square root of this last term, so 3/4. Then we also combine like terms on the other side of the equation. So I need to combine these two fractions. They need a common denominator, so I'm going to multiply top and bottom of this fraction by 4 to get a common denominator of 16. So that gives me a negative 20 over 16 plus 9 over 16. So I end up with the binomial x plus 3/4 quantity squared equals a negative 11 over 16. Then my last step is to solve this equation using the square root property. So if I square root both sides, the squaring and the square rooting are inverse operations and they undo each other. So I have x plus 3/4 left there. And then the square root property says that whenever you square root both sides of the equation, you have to write plus or minus on this. And so we have plus or minus square root of a negative 11 over 16. Now I'm going to subtract 3/4 from both sides. This will cancel. And I have x is equal to, this number is irrational, and this number is rational, so I can't put those together. So I just write that, negative 3/4 plus or minus. And then up here I have the square root of a negative 11 over the square root of 16. Whenever you have a radical and a fraction underneath, you can break it into two separate radicals. So that's what I did. Because there's a couple more things that I need to simplify here. X equals, I'll just copy negative 3/4 plus or minus. In the numerator, whenever you have a negative under the radical, under a square root, that's an imaginary number. So you have to bring that negative out and separate it away from the square root of 11 here in this case. So I'd have square root of negative 1, which is I, and then the square root of 11 I'll leave alone. If you can't remember that, the square root of negative 1 is the same as I. It's defined that way. So this numerator was square root of negative 1 times square root of 11. Alright, then also the square root of 16 we know is 4. So this is my solution for that quadratic.